lecture note. So we lose 1 hour here. Okay. Now we will speak about more interesting subject and more fun subject. So we will play a little bit with each other. Actually, it's like playing this subject, graph theory. I will not make it complicated. It's very interesting, and you can have some fun playing with graph using this part of our lecture. So first we take some definition, then we will see how to use this graphs. What is a graph? Actually, graph is a collection of dots. We called each dots like this dot, and this dot, or nodes. We called them you mean the cryptograph? I think we should take it. So I will make the graphs in 2 parts, and hopefully we will take the cryptograph, inshallah. Hopefully we can reach it. At least we will have 1 lecture about the cryptograph. Okay. Cryptography. Okay, then the graph, it's dots. We call this dots vertices. This is the plural. The singular, it's vertex. Each one vertex, or all, it's a vertices. And there is lines connecting each edge, or each vertices is connected by edges. So we have vertices and we have edges connected these vertices. In this example, we have 1, 2, 3 vertices, and we have how many edges? 1. Okay, I think I have to change the battery of my mouse. Just a moment. Okay, I could not find the battery. Okay, let's continue. So we have 1 edge. It's actually, as you can see, it's a loop edge, and we have 2, 3, 4 edges, and 3, 1, 2, 3 vertices. Okay, I think it's simple. There's many things in our life, many type of information that we can illustrate it and analyze it using objects and relation between objects. For example, we can analyze the relation between you and your friends. You have, for example, Ahmed and Ali as your friends. Then you have relation. So we can consider you as a vertex, Ahmed as a vertex, Ali as a vertex. So we have edge relation between you and Ahmed, between you and Ali. What about if Ahmed and Ali also friends? So Ahmed and Ali also have edge, have relation. So we can illustrate or analyze many types of objects and their relationship using graphs. Then we can use the graph theories to solve some problems in the real life. we have two special cases of edges, loops, like this one. Loops start from the vertex and return to it, to the same vertex. And we have isolated points like C here, do not have relation with other part from the graph. We will avoid this isolated points. We don't need graphs with isolated points because we cannot follow the relations. Okay, so we are looking only for graphs that do not have isolated points. Okay, good. Example for represent some situation. If we have during 1 week, Angela, Bob, its names, okay, Charlie and David play games. As this, Angela play with Bob. It doesn't matter what's the name of this game. Bob, Charlie, and David play this game with each other. Angela, Bob, and play this game. Doesn't matter the name of the game, but we can see that there's a relation between Angela, Bob, which is one game, Bob, Charlie, David, which is another game, Angela, Bob. So we can represent this relation. For example, Angela played with Bob. So we have Angela, Bob, Charlie, David. We have Angela played, for example, it's difficult with this batteries. So we have Angela and Bob played, for example, war, we said here. Then there is another relation between Angela and Bob. Yes, Angela and Bob played Mancala. I don't know what's this game. So there is another edge. Each edge considers the game that they played. So this one, the game, we don't want the name of the edges, only to show you that the edges consider the games, which is the relation between the two nodes or the two vertex, Angela and Bob. Okay, also Bob played with Charlie, so Bob played with Charlie, and Bob played with David, so Bob played with David. Okay, Charlie also played with David in this game. So Charlie and David. So we can represent this situation using a graph. We can actually draw a graph to represent any node or anything from our real life, like cities, like people, like students, and the relationship between them as the edge. Okay, so a graph have vertex or vertices and edges that represent the relation between this vertex. Okay, we come to the formal definition. If we have a graph G, we write it like this: G equal V and E. This V, all the vertices, E, all the edge between the vertices. Okay. About the direction, we have a unidirect graph and directed graph, unidirected graph and directed graph. It's simple. Unidirected graph doesn't matter the direction between the vertices from V1 to V2 or from V2 to V1. We don't care this edge, which direction. But if we have direct graph, it's matter for us. Is it the edge come from V1 to V2 or from V1 to V2 to V1? Okay, so if we have undirected graph and inside this we have two vertices, U and V. So U and V, if they have edge, we call them adjacent neighbors because they have edge. Okay, this only term. So adjacent vertices when they have edge. If we have edge between U and V, or in another term, V1 and V2, we have edge between them, then V1 and V2 adjacent or neighbors. Here we have edge between V2 and V3. Okay, so V2 and V3 also adjacent or neighbors. And the edge between them, which is E2 here in this example, we called it incident. Incident. It's incident, it's the edge connected between adjacent. Okay, good. It's just some terms. Okay. So to write all the neighbors of vertex V, we name it N, which is neighbor V. So it's a set N V1. What N V1 equal? Actually, it's equal V1 because we have here, you see, V1, it's a neighbor for V1, and we have V2. So all neighbors of V1, it's V1 and V2. Neighbors of V2. What we have? We have V1, we have V3, and we have here edge to V5. And so on. So we can write the neighbors for each one. One important thing to know the degree for each vertex and to know if it's even degree or odd degree. We need this for some real life problems. Okay, for example, in this graph, we have vertex S. You will see how many lines or how many edge come or go outside this vertex. So it becomes a degree. So S have 1 as a degree because it have only 1 edge. M have 3, 1, 2, 3. So the degree of M is 3. A have 2, 1, 2. So the degree of A, 2. R, 3. And T have 1, 2, 3. So it's degree 3. I think it's very simple, yes? So we can found. So we can found the degree. then we can define if this degree even or odd. We need this later in some theories. So the degree of S1, this means it's odd. The degree of M3, this means it's odd. The degree of A2, this means it's even. The degree of R3, which means it's odd, and T, odd. Okay, so we try to find the degree of these vertices. So we have A, B, C, D, E. What is the degree of A? It's 1, 2, 3, 4. So the degree of A is 4. What is the degree of B? B vertices have 1, 2, 3, 4. So it's 4. What is the degree of C? Who knows the degree of C? No, it's not 2. The degree of C is 3. Because when you have a loop, you consider it's 2. Because we have 1 and 2. So it's come out and return. So we consider it 1, 2, and this one become 3. So the degree of C is 3. When you have loop, you consider the loop as 2, and we have this one between C and B, then it become 3. Okay, the degree of D, 1, 2, 3. The degree of E, it's 1, 2. One, 2. Now which one odd, which one even? This one even, even, odd, odd, even. Okay. Okay, which one's the correct answer? What is the this graph has? How many edges? How many vertices? And which one of these statements are correct? How many edges? 1, 2, 3, 4, 5, 6. Okay, then we have how many edges? 6 edges. How many vertices? 4. So we have 2 choices. Okay, which one correct? If you can see this 3, this one 3, this one 3, this one 3, the degree. So all of which odd. So this one's the correct one. We have 6 edges, 4 vertices, and all vertices is odd. Okay, good answer, Mustafa. Correct answer. So we have 6 edges, 4 vertices, all odd. Okay, which the correct answer here? Okay, the number of edge and vertices is correct for all. Okay, none of which are odd. If you can see this one odd, so this one wrong. Exactly 2 of which are odd. Okay, 1 odd, 2 odd, 3 odd. So this one not correct. Exactly 4 of which are odd, or all of which are odd. you can see that this one even, so this is not correct. So we have 4 odd. 1, 2, 3, 4, 5. This one have 5. This one 3. This one 3. This one 3. This one 2. So we have 1, 2, 3, 4 odd and 1 even. So this is the correct answer. Okay. Draw a graph. Let's say playing. Draw a graph that have 4 vertices, all odd, and 5 edges. We can draw here. Okay, let me now share the whiteboard. Okay. Now we need 4 vertices, all odd, and 5 edges. We need to draw 4 vertices, all odd, and 5 edges, with 5 edges. 5 edges. Who know how to write? Any suggestion? You can use your mouse and draw in this whiteboard. I think you can use the whiteboard and draw if you want to draw a solution. This is a question. We have 4 vertices in our graph, all odd vertices, and we have 5 edges. We need to draw this graph with this specification. Anyone want to try? Okay, good. Okay. 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 You have 5 like this. Okay. Okay, stop. Okay, you bought 1, 2, 3, 4, 5. Okay, let me help you. Let me help you. Wait, wait. Okay, stop. It's not correct. You will not find it like this. Wait little bit. Wait little bit. This one incorrect because this odd, but this one even, and this one even. So let me try to give you some hint. Okay. To find solution, first you need to know the degrees, the total of all the degrees. The total of all the degrees, it's 2m, which m, the number of edge. So if we have 2 edge, so the total of degrees for all the vertices is 10. So to have all odd, we can have V1, V2, we have 4 vertices, yes? V3, V4, we need from V1 to be, because the total, the summation of all the degrees here will be 10, depending on number of edge, because edge connect between you cannot see the whiteboard. If you see the whiteboard, it's okay. I mean, my mouse, you cannot see the mouse. You can see the effect. You can see what I'm writing. It doesn't matter to see my cursor. You can see what I write here. You see V1, V2, V3, V4. Okay. Let me, I don't know what here. Okay. Hopefully it will not start from the beginning. Oh, actually we started from the beginning. It's okay. Then we need 4. Oh, who did this? Why it's like this? You can see now, but actually it's very thin. Yes. It's not zooming here. Zoom up like this. Okay. I think now, okay. Yes, but I need to use the control with it. I just get it. Okay, so why it's not going to? So we have 4 vertices, all odd, and we have 5 edges. I want to ask you, each edge will connect 2 vertices, yes, or the same vertices itself. Okay, from this we can conclude that the number of degrees will be 2 multiplied by number of edge. So we have 10 degrees. And we need all the degrees to be odd. So we have V1, V2, V3, V4. And the summation for degree for all of them should be 10. So to make the summation 10 and all odd, we can take this one 3, the degree of it, and this one 3, and this one 3, and this one 1. See the summation? It's equal 10. So like this, we can have 5 edges. To have 5 edges, we need 3 coming out from V1, 3 coming out from V2, 3 coming out from V3, and 1 from V1. So now try to draw using the new information. You can draw here. Okay, only one. One of you try to draw now using this information. Anyone want to try? I will try myself. Okay, let me use the blue. Now, as I said, we have 4, 1, 2, 3, 4. First one connected with 3. Connected with 1, 2, 3. Second one connected with the 3. Who's the 3? Could be this one. Also. And it's already connected here. And it's cannot connect here because I need this one to have 1 degree. This one to have 3 degrees. This one to have 3 degrees. This one to have 3 degrees. As I analyzed here, 3, 3. So this one finish. This one finished, have 3. This one not finished, have 2 only. And this one have 2. So we can connect another time between this 2 dots. So like this, the solution. Count the edge. Count the edges. We have 1, 2, 3, 4, 5. So it's correct, 5. Is it odd all? Yes, this one odd, this one odd, this one odd, this one odd. So to draw this graph, okay, to draw this graph, I need to know the degree for each vertex, and from number of edge, I have the total number of degrees. Okay, another example. In the next example, we have 4 vertices, all odd, and 3 edge, and don't use the loop. So, in this example, the next example. The next example said, we have 4 vertices, 4 vertices, all odd, okay, and three edges. Three edges. No loop. We don't have any edge come in out from the same loop. No loops. Anyone want to try to analyze this one? You can use the whiteboard. Okay, I will try. We have three edges. So what's the total number of degrees? No, first analyze. Like this, you will not get the correct solution. You have to analyze this. To analyze this, first find the number of degrees. We have three edges. This means we have 6 degrees. Now, you know that we have V1, V2, V3, V4. Yes, so we need V1, V2, V3, V4 to have odd degree, and the total of degrees should be 6. How to do this? 1, 1, 1, 3. Good answer. Continue. You are like a star. Yeah, continue. You're drawing out of my screen. No, it's not correct. This one not correct. This one not correct. Wait, little bit, wait. Let me help you. Okay, wait. We said that V1, V2, V3 have degree of 1, yes, and V4 have degree of 3. So we can connect between V1 with V4, V2 with, so we have like in the center V4, and around it we have 3. You see here? You can know that this one have degree 3, this one have degree 1, degree 1, degree 1. I will give you opportunity to try next one because we already solved this one. Okay? We solved it because we need 3 edges. 1, 2, 3. So one vertices will have 3 edges out and each one have degree 1. It's the correct one. This one odd, 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 and we have 3 edges for vertices. Okay, now another example. I told you it's like a playing, yes, but it's important in the real life in some examples. Okay, so you can use this to move the screen. Okay, in the next example, Oh, seems I forget to put the next two examples. So let me just bring the examples. Wait a little bit. Because I said total number of degrees, we know that each vertices have degree. Okay. The total number of degrees for all vertices, the summation, vertices 1, vertices 2, okay? If you make summation for all the vertices, it will be 2 by number of edge. Number of edges. So if you have 3 edges, then the total summation for the degrees for all vertices will be 2 multiply 3. If you have 5 edges, then it will be 2 multiplied by 5, which means 10, and so on. So it's double the edges. Why double the edges? Because the degree, it's meaning there is connection between vertices, yes, and each edge connect 2 vertices, so it will give degree for 2 vertices. That's why multiply number of edge by 2 will give you the total degree for all vertices. Okay, I will give another example here. Let me search for it. I think from here. Okay, example 3 said we have 3 vertices, not 4 now, it's 3 vertices. Okay, and we have exactly one even, one even. Okay, and 4 edges. One even, this means 2 odd. Okay, one even, 2 odd, and number of edge 4. Okay, let me analyze this for you, or you want to try, Hassan? You want to try analyze it here? Okay, Mustafa, go ahead, try. First, you need to find the total number of degrees. This first step. You are drawing directly without any analysis. You will not get without any analysis. So this one not correct. Okay, you are analyzing now. What is the total number of edges? 8. So you need 1 even and 2 odd. Okay. So analyzes the degrees. Total number of degrees 8 degrees. Okay, correct. Then it's 3, 3, 2. Like this, you will have 2 even, 1 odd. Correct. Now go ahead. You can draw. Please try drawing in this box so I can see it. Inside this box. Only one, please. Okay, let me try this one myself. Okay. Okay, wait a little bit. This one not correct. Okay. Look, I will try it. Let me try it here. We have 3 vertices. 1, 2, 3. Okay. Then V1, V2, V3. Okay, V1 have degree 3, V2 have degree 3, V3 have degree 2. Yes? So we can connect V1 with V2, V1 with V3. Okay, V2 with V3. This is the first step. Now, if you look, V3 already have 2 edges, so we finished V3. V1 and V2, we can connect between them like this. They can have 2 connection. So they can have 1, 2 connection. Let me just. If you look, now V3 have degree 3, V1, and V2 have degree 3. And how many edges we have? 1, 2, 3, 4. So we have 4 edges, 3 vertices, 1, 2, 3, 1 even, which is this one, and 2 odd. Like this, we can draw. Try not to draw loops, okay? Loop from one to itself. Try, just if you need it, try to draw it. First, try without drawing the loops. Then, first you need to find the degree. Then, according to specification here, you'll know which each one, how much the degree, then you can draw. This example, last one, you have 3 vertices, 1 odd, and 4 edges. Try to draw this one at your home, okay, and tell me next time what happened with you. 3 vertices, 1 odd, and you have 4 edges. Okay, because we already finished our lecture today. Try this one at home. Next time, inshallah, I will discuss the solution for it with you. Okay, see you inshallah next week. Or Eid Mubarak, I think after the Eid, inshallah. See you. Assalamu alaikum.